shifting ease of an automatic. Here's how they work. Dual clutch transmissions contain the traditional elements of a manual and are driven by a twin or dual clutch module. The manual elements include helical gears on parallel shafts to create different gear ratios, synchronizer systems to ease gear engagement, and an actuated shift fork system to select the appropriate gear ratio. The clutch module can either be dry, like a conventional manual, or of a multi-plate wet clutch variety, like those used for shifting clutches on step-level automatics. This demonstration will show the wet clutch variety. Although a traditional manual transmission uses a singular input shaft, the gears in a dual clutch transmission are driven by one of two input shafts. Typically, the odd-numbered gears are driven by one shaft and the even by the other. Hydraulic fluid pressure is used to actuate the respective clutches as needed. Fluid is used to lubricate and cool the clutch as well. When the driver puts the gear selector in drive, the appropriate shift forks will cause the engagement of first gear. When the driver presses the accelerator pedal, the outer clutch will be engaged to launch the vehicle from rest, driving power through first gear. Much like a manual transmission, the DCT uses synchronizers, which are friction devices that match the input shaft speed to the selected gear speed during a change. The cone of the gear makes contact with the collar before the gear teeth mesh. The friction between the cone and collar brings the two to the same speed prior to teeth engagement. This creates smooth gear changing. As the vehicle accelerates in first gear, the second gear is also engaged by way of the synchronizer system to the inner non-engaged clutch. When it's time for the vehicle to shift into second gear, the outer clutch will disengage and the inner will engage, thus directing the power through second gear. The exchange of power flow from the outer to inner clutch occurs in a few hundredths of a second, which is quicker than the typical shift time of a step-level automatic. As the vehicle accelerates through second gear, the shift fork system will deselect first gear and select third. When conditions are appropriate, the inner clutch will disengage, the outer will re-engage, and the power will then flow through the pre-selected third gear. This back and forth power flow between the outer and inner clutches continues throughout the gear ratios, as the shift fork system continuously anticipates the next needed ratio and pre-selects the appropriate gear. Power now flows through fourth gear. And into fifth. And finally into sixth, as the transmission shown is a 6-speed gearbox. The innovative dual clutch design and precise control that has been demonstrated allow for much quicker gear changes than manual or planetary automatic transmissions. This enables improved performance and fuel economy, which will make dual clutch transmissions a continued option for...
Place the transmission on a strong workbench. Before turning the transmission on its side, use the two transmission plugs to plug the breather ports on the transmission. Turn the transmission on its side and use the transmission stabilizer to support it. Using a flat blade screwdriver, remove the circlip holding the sprung-driven hub in place. The small magnet tool can then be used to remove the clip. Remove the hub assembly out of the clutch. Remove the clip holding the clutch bearing on the shaft with the circlip pliers supplied in the kit. Rotate the clutch assembly such that the three pulling legs can be secured onto the clutch assembly with clearance on the bell housing. The pulling tool can then be mounted onto the three legs using the special dolly over the support shaft. Use a ratchet and socket to slowly pull the clutch assembly off the support shaft. Carefully lift the old clutch assembly out of the transmission and remove the tools from it. Remove the cover plate from the side of the transmission to uncover the actuation forks. Remove the old nose cone and clutch fork assembly. Carefully clean the bell housing out, removing any dust and contaminants that may be present. Remove the old pivot ball and insert the new pivot ball supplied in the kit. Install the new bottom clutch fork and bearing on the pivots. Install the new mounting bolts for the nose cone with thread lock. These should be torqued up to 8 Nm plus 90 degrees. Install the top fork and bearing onto the pivots. Install the thickest shim on the large bearing. Install the checking mandrel for the large bearing on the shaft with the checking mass. If the shim guide does not fit in the groove, then change the shim size to the next smallest size until the shim guide is a snug fit in the gap. Install the small bearing with the thickest shim and use the small mandrel and the same mass to check the fitment of the shim guide. Adjust the shim size until the shim guide is a snug fit in the gap. Apply a small amount of spline grease to both splines using a brush. Remove any excess with a rag. Apply a very small amount of oil to the support shaft to assist the bearing to be pressed on. Carefully lift the clutch assembly into place, aligning the large spline on the shaft. Check that this bottom spline is aligned by measuring from the bearing race down to the shaft. If this measurement is more than 8 mm, then the spline is not aligned. Mount the 3 pulling posts to the bell housing bolt holes. Select the correct mandrel to suit the bearing race and mount the crossbeam on the posts. Carefully press the clutch assembly down onto the shaft using a torque wrench, watching through the inspection port on the mandrel. Ensure the torque does not exceed 16 Nm during this process. Install the new clip on the support shaft on the top side of the bearing. Mount the dial indicator on the bell housing and set it up on the bottom clutch disc. Using 2 lifting hooks, check the float in this clutch disc. The disc must move between 0.3 mm and 1 mm to ensure that there is not too much clearance for engagement and enough clearance for release of the disc. Check the lift in 3 spots on the disc to be sure of the clearance. Install the top driving hub with the alignment mark indexed with the disc. The disc may need to be moved to align with the hub. Carefully insert the circlip and ensure it is aligned with the gap where the indexing mark is on the hub. Move the dial indicator back into place on the top of the hub assembly. Check the float on the top disc by using the lifting hooks on the hub. The specifications need to be the same as the bottom hub, where the movement needs to be between 0.3 and 1mm of movement. Check 3 spots around the disc. If the clearance on the disc is too large, then the shim size needs to be increased on the corresponding bearing. Do a final check there is no movement in the clutch forks on the outside before reinstalling the fork cover. Finally, remove the access port cover and use this opening to rotate the clutch assembly. You can then index the clutch assembly with the flywheel.